Hello students, in this video we'll see how to compute the determinant of a matrix by multiplying it by a special matrix that puts the product into a special form. Let's compute the determinant of the matrix A, B, B, A, C, D, D, C, C, D, D, C, A, B, B, A. What we'll do is we'll first compute the determinant of an auxiliary matrix and then multiply that auxiliary matrix by this matrix. So what I'll do now is I'll consider the determinant of this matrix B. And what is this matrix B? This is going to be the determinant of 1, 1, 1, 1, 1, 1, negative 1, negative 1, 1, negative 1, negative 1, 1, and then a 1, negative 1, 1, negative 1, right? And we're going to see that this, multiplying this matrix B by our original matrix will put it into another special form, okay? So how do I do this determinant? Well, I would use elementary row operations because there's a lot of symmetry in this matrix. So I'll say that this is equal to the determinant. I'll leave the first row the same, 1, 1, 1, 1. And then I'm going to add the first row to the second row, the third row, and the fourth row. I'll get a 2, a 0, and a 0. I will get a 2, a 0, and a 0, and a 2. I will get a 2, and a 0, and a 2, and a 0. And we got lots of zeros by doing this, right? So now I can expand along any row or column over here. So what I'll do is I'll choose to expand along this last row, this last column over here, because there's at least 2 zeros, and that makes the calculation a lot simpler. This number here is plus, minus, plus. That's a minus entry, and that's going to be a plus, and that 2 is going to be a minus 2. Okay, so when we do the cofactor expansion, we're going to get a minus over there. Okay, so what we have over here is we're going to have two determinants. It's going to be minus the determinant of what we get when we punch out the row and column in which 1 resides. That's going to be a 2, 2, 0, 2, 0, 0, 2, 0, 2, like that. And then minus 2 times the determinant of what we get when we punch out the row and column in which that 2 resides. We'll punch out this and this over here, and I'll have a what? I'll have a 1, 1, 1, and then a what? And then a 2, 2, 0. And then a 0, then a 2, 0, 2, like that. Okay, great. So now let's compute these determinants one by one. So this first determinant over here, let's just expand it along. We can expand along this column, this row over here, right? So that's going to be a plus over here. That's going to be a minus over here. So I have a minus, minus 2. That's going to turn into a positive 2. Positive 2 times what determinant? Times this determinant over here, the determinant of 2, 0, 0, 2. That's what that first determinant is over there. That's going to be easy to compute. And now this thing over here, we can choose to expand. We can just expand along, say, along the first row for practice. So plus, minus, and plus. Great. And so what we have over here, so we're going to have minus 2 times the quantity of a 1 times a 4. That's a 1 times 4 for that first subdeterminant. And then a negative 1 times what? Negative 1 times what we get when we punch out the row and column. So I'm going to have a 2, 0, 2, 0. So that going to be a 4. And then finally, if I do this last row, I'm going to get a what? I'm going to get another negative 4 over here. So another negative 4. Okay, so one of these 4s cancels out. That gives me, so this is going to be a 2 times 4. That's going to be an 8. That's going to be a 2 times 4. So this is going to be an 8 plus 8 over here. So the determinant of this matrix over here is 16. So the determinant of B is equal to 16. Now you might say, oh, well, how does that help us? Well, let's see what happens when I take, let's call this determinant of our matrix. Let's call that matrix over there A. Of course, A is a function of little a, B, C, and D, right? Excellent. So now let's multiply our matrix A by this matrix over here, B. So we know that the determinant of A times B, so the determinant of A times B, determinant of A times B is, of course, just the determinant of A times 16, right? Because by the properties of multiplication of the determinants, right? But what is A times B? This is the determinant. Now let's see where we can get over here. Well, now if I do 1, 1, 1, if I do first row, first column over here, so let's actually just write it out. A, B, B, A, C, D, D, C, and then C, D, D, C, and then A, B, B, A, like that, times the matrix B, which is 1, 1, 1, 1, 1, 1, 1, and then 1, negative 1, negative 1, and then negative 1, negative 1, 1, and then 1 with a negative sign, 1, negative 1, right? Okay. All right, so now at this point, what we're going to do is if I multiply this first row by this first column over here, second row, second column, third row, first column, fourth row, fourth column, we see we're going to have an A, a B, a C, and a D. A B, an A, a D, and a C. A C, a D, an A, and a B, and a D, a C, a B, and an A. So if I do row dot column for the first entry, what I can do is I can set up new variables over here. What I'm going to do over here is I'm going to set alpha to be A plus B plus C plus D, okay? So if we set that to be our alpha, this becomes what? This becomes determinant of the first row, row dot column is all gonna be alphas. So alpha, 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 like that, okay? All right, and so now let's look at the second row over here. So what we're gonna have over here is, if I do a second column rather, if I do A, B, C, D, and then what? And then I'll have an A, a B, a negative C, and a negative D, right? So let's set beta to be A plus B minus C minus D, okay? So this first entry over here will be a beta. Then the second entry over here, I'll have an A and a B with the plus ones, and a C and a D with a negative sign, so that the order doesn't matter, so that's gonna also be beta. And then if I do these things over here, the C and the D will become positive, and then the A and the B will become negative, so that's gonna be negative beta and negative beta. So I get negative beta and negative beta. Let's look at the third column over here. I'm gonna call it gamma. What should we call it gamma? Let's call it gamma C minus D minus A plus B. So that first thing over here will be what? I'll have a C, a minus D, a minus A, and a B. So that first entry over there will be gamma. Then if I do the next row, I'm going to have a positive B and negative A, a positive B and negative A, right? And so let's do this carefully. So a positive B, a negative A. So I have this backwards, I think. So I have a negative. So I want this to be a plus A. So let's change that. I have I want this to be gamma. So let's modify this. So I have the sign error over here. So let's change out what gamma is. I want that to be, make sure we're okay here. So what will gamma be? So gamma is going to be what? Gamma is going to be a positive A, a negative B, a negative C, and a positive D. Then in that case, that will be gamma. Then what will the second row be? It'll be a positive B, a negative A, a negative D, and a positive C. So that's going to be negative gamma, like that. Let's look at the next one. I'm going to have a positive C, a negative D, then a negative A, then a positive B. So that's also negative gamma. And finally, I'll have a what? A positive D, a negative C, a negative B, and a positive A. So that entry over there will be gamma, right? And finally, let's look at delta. So let's see what we get when we do the fourth row. Okay? So if we look at the fourth column over here, we'll have a positive A, a negative B, and then a positive C, and then a negative D. So then that will be a delta over there. Okay, that's the first thing. Then we'll have a what? The next entry is going to be a positive B, a negative A positive D, and a negative of the C, right? So that's going to be negative delta. Then I'll have a positive C, negative D, positive C, negative D, then a positive A, negative B. That's exactly delta. And then the last entry over here is going to be what? The last entry is going to be a D, a minus C, D minus C, and then a B minus A. So that's negative delta over here. Now we're in great shape, because what I can say now is I can say that this is exactly equal to what? This is exactly equal to alpha, pull out an alpha from the first column, pull out a beta from the second column, a gamma from the third column, and a delta from the fourth column. I got alpha, beta, gamma, delta. And then times what? Times the determinants of just what's left over will just be the matrix 1, 1, 1, 1, 1, 1, 1, and then 1, negative 1, negative 1, and then negative 1, negative 1, 1, and then negative 1, 1, 1 with a negative sign over there. But that's exactly just the determinant of B. So this is alpha, beta, gamma, delta times 16. So we've just proven over here that the determinant of A times 16, which is the determinant of A times B, is equal to 16 times alpha, beta, gamma, delta. So therefore, by canceling the 16 on either side of the equation, we get the following relationship. We get that the determinant of A is alpha, A plus B plus C plus D, times beta, A plus B minus C minus D, and then gamma, A minus B minus C plus D, and then times delta, A minus B plus C minus D. So our determinant of A is computable as this symmetric product over here by introducing this auxiliary matrix and computing the matrix product. Thank you very much.